Hello everyone, myself Hans. Today we are going to solve the given problem based on Laplace transform. Question is given, evaluate the Laplace of cos 2t minus of cos 3t upon t. Let's solve the problem. Given Laplace of cos 2t minus of cos 3t upon t. We have to calculate the value. First, we have to find the value of cos 2t and cos 3t. Laplace of cos 2t and Laplace of cos 3t. And we know that Laplace of cos at is given by s upon s square plus of a square. Here, when we have to find Laplace of cos 2t, in place of a is 2, so we have to write here s square upon s square plus of 4. A square, here is a is 2, so we have to write here 4. And when we have to find the Laplace of cos 3t, this is given by s square upon s square plus of 9. Here a is 3, so we have to put the value here, and we know also that is we know that Laplace of f of t upon t is given by integral limit is s to infinity fs ds. So we have to put here like in the form of Laplace of cos 2t and cos 3t is given by s square upon s square plus of 4 and s square upon s square plus of 9. Here like a form, this is f of t upon t. So we have to write here Laplace of cos 2t minus of cos 3t upon t is given by, here integral limit is s. Here we have to let cos 2t and cos 3t is ft. So we have to consider ft upon t, and so we have to put here s to infinity, and putting the value, this is given by s square upon s square plus of 4 minus of s square upon s square plus of 9. We have to let us assume here, let f of t is equal to cos 2t minus of cos 3t. Then we have to like a form, that is Laplace of ft upon t. We can proceed with integral limit is s to infinity fs ds, and we have to calculate cos 2t, Laplace of cos 2t and Laplace of cos 3t is given by the formula this is. And further we have to expand. We can also once again s square plus of 4, and once again we have to write here, we have to putting the value here once again. Here is Laplace of cos 2t, and here is ds also, ds. This is ds is missing, and further we have to solve. This is given by integral limit is s to infinity on integration s square ds upon s square plus of 4. We have to let here s square, once again we have to let here, we have to let s square plus of 4 is equal to t, then 2s is equal to 2s ds is equal to dt, and when we have to take s square plus of 9 is equal to t, this gives 2s ds is equal to dt. So we have to put in here, we can separately write this is s square upon s square plus of 4, this is ds minus of integral is s to infinity, and this is s square upon s square plus of 9 into ds. Here we have to let in the first part s square plus of 4 is t, and second part we have to let s square plus 9 is t. We can also put the value here. Putting this is given by integral limit. When we have to put here, also change the limit also. When we have to put s is equal to, once again, when we have to put s is equal to infinity, we get infinity, and when we have to put s is equal to s, then we have to get also the same. So we have to write here integral of s to infinity integral limit, and here is s square ds, once again 2s ds. We have to put the value of ds here. So we have to putting the value of ds. From here we get s square is t, then once again s square plus of 4. Sorry, this is s upon s square plus of a square, not s square. Here is some mistake. Formula is using Laplace of cos at is given by s upon s square plus of a square. So we have to write here only s, not s square. This is s square, and we have to let here s plus 4 is equal to t, and s square s plus 9 is equal to t. Then we have to get this is ds. Sorry, this is s square, in denominator is s square. Then we have to get this is 2s ds is equal to dt, and here is 2s ds is equal to dt, and we have to replace ds. The value of ds is given by here. This is ds is equal to dt upon 2s, and from here we get ds is equal to dt upon 2s. So we have to put in here, we get this is s, and s upon t. We have to let s square plus of 4 is t. So we have to write here t, and in place of ds we have to, in the first part we have to put in dt upon 2s, and minus of integral limit is s to infinity, and here we can also put here s upon s square plus of 9. We can also take here t. So we have to write to t, and in place of ds we have to put in dt upon 2s, and from here s to s is cancelled out. Then the remaining is 1 by of 2. Integral limit is s to infinity, and this is dt upon t, and the second part of the integral is also given by 1 by of 2 minus 1 by of 2, and this is s to infinity, and this is dt upon t, and we know that the integral of dt upon t is log t. So we have to write here, we have to writing here, this is taking 1 by 2 common from, this is 1 by 2 is taking common, and dt upon t is log t, and we have to putting the value s to infinity, and minus of here also dt upon t, the second part of the integral. This gives log of t and dt, and we can also here change, if the first part we have to take in t, then we have to let second part is y. Not confused here. So we have to write here this is dy, not same, this is dy. We have to put in, once again, the first part we have to let t, and the second part we have to let y. So we have to here, this is dy, then we have to get this is, once again, dy s square plus of 9, this is 2s upon dy, this gives dy upon, this is y. We have to let here, and further we take similar both t we have too much confusion, so we have to write here the first part of the integral is t and the second part we have to consider y. So we have to write here this is log y and putting the limit here s to infinity and solving we get 1 by of 2 when we have to putting the value of log t in the first part, this is given by log of, we have to consider here s square plus 4 is t, s square plus of 4 is t, and here is s to infinity and minus of, in the second part of integral we can consider s square plus 9 is y, so we have to write here log of s square plus of 9 and the integral limit is s to infinity, and further we have to put the limit, this is given by 1 by 2 is taking outside, and here when we have from here we can also write here once again, we have to write in log of s square plus of 4. When we have to apply the, we can also write this is log of 1 plus of 4 upon s square, and this is limit is s to infinity, and minus of log of 1 plus of 9 upon s square, and here limit is s to infinity. When we have to apply the upper limit infinity, when we have to apply the upper limit 1 by of 2, and here we have to apply upper limit 4 upon s square. In place of s we have to put infinity, 4 upon infinity is 0, so we have to get here log of 1, and when we have to put log in place of s we have to put s, we get the similar result. This is given by minus of, on applying lower limit of this part, this is log of 1 plus of 4 upon s square. Similarly we have to put in for this limit also, this is minus is taking outside, and here when we have to apply the upper limit here we get log 1, and when we have to apply the lower limit s we get the similar result, this is log of 1 plus of 9 upon s square, and further we have to solve, here we get 1 by of 2 and log 1 is 0, and minus here we have to consider taking LCM here, this is s square minus of log s square plus of 4 upon s square, and here is minus, here is also 0, log 1 is 0, so we have to get minus of 0, and here is plus of log, we have to taking LCM also here, this gives s square plus of 9 upon s square, and the remaining is here once again. We have to solving, this is 1 by of 2 and here is minus of log, so we have to write first, this is log of plus of log s square plus of 9 upon s square, and here is minus of log s square plus of 4 upon s square. We have to use the property of log m minus n, this is given by log m upon n, this is given by log m upon n, this is 1 by 2 is outside, and here log upon m upon n, this is given by log of s square plus of 9 upon s square, and this is m and this is n, so we have to write here s square plus 4 upon s square, and we have to cancel out the term s square to s square is cancel out, and the remaining is 1 by of 2, and here is log of s square plus of 9 upon s square plus of 4. This is the required solution of the given problem. Thank you class, and thank you for watching.